Okay, this video is recorded to help my students to understand Appendix C. Appendix C is an instruction set for an imaginary computer. This imaginary computer is much simpler than the real computer, so its instruction set is also much simple. In the real computer, normally one instruction has 32 bits, but for this, each instruction only has 16 bits, which is 4 digits of the hexadecimal number. So in this table, in this appendix, he tell you the first column is operation code, OP code. Okay, operation code. Another, the second column are the operands. So you can see each instruction is 4 digit. So the opcode is only 1 digit, and the operand have 3 digits. And then for each instruction has description here to explain this instruction and give you an example to tell you how to use this instruction. Let's say first instruction. First instruction, the opcode is 1. That means this instruction first digit is always 1. Then the rest 3 digits, let's give them a name. Second digit called R, third digit called X, the last digit called Y. Then he said this instruction means load the register R with the bit pattern found in the memory cell whose address is XY. Now, which means XY together as a 2 digit, which is 1 byte, right? 8 bits is a memory location, okay? Then R is 1 digit, right? 4 bits, which refer a register. If you use 4 bits to refer register, so this computer can, this imaginary computer totally can have 16 registers, right? If you use 1 digit, because your 1 digit could be 0, 1, 2, 3, 4 up to 9, then A, B, C, D, E, F. F means 15. So from 0 to 15 refer to the register number. So you totally can have 16 register in this imaginary computer. Okay. So then he gave an example. For example, if you see an instruction is 14A3, what that mean? You see 1 means is load, because operation code 1 means load. 4 is a register number. That means then A3 is a memory address. So which means well, the whatever stored in the memory address A3 will be loaded into register 4. That means suppose you have 5 in the memory with address A3. Now the register 4 has value 5 installed. Okay, store into it. Now the second one still is load, but this load is different. This load opcode is 2. This load register R with the bit pattern XY. Now this time XY is not treated as a memory address. XY together is treated as a number, So for example, 20A3, that means the value A3 as a number will be loaded into register 0. Okay, so you have 2 load instruction for this instruction set. One load instruction is with opcode 1. Another load instruction with opcode 2. But those 2 instructions load a different thing. When the opcode is 1, he will load the value in the memory address XY into the register R. When the opcode is 2, it will load the value of with bit pattern XY into the register R. So after you understand those, then you can see the rest will be simple, right? If the opcode is 3, which means you will store. That means 3RX means store the bit pattern found in register R into the memory cell whose address is XY. So give you an example. 35B1. When you see this instruction, you will know 3 means store, 5 is register 5, right? B1 is the memory address, memory cell with the address B1. So which means you will store whatever value in the register 5 into the memory cell with the address B1. Okay, so this is store. Now, then some instruction, for example, some instruction you do not need to use all the 3 operands. For this instruction move, his opcode is 4. Then the second digit is 0. actually means we really don't use it for this case. RS, so it means move the bit pattern found in register R to the register S. So, for example, 40A4. Now, 4 means move. A is the register A. 4 is register 4. So you move whatever in register A, which means you make a copy to the register 4. Notice whatever in register A still in register A, but that value just made a copy to the register 4. Okay? Then if your opcode is 5, means add. Now add you need to have 3 registers. One is the source register, one another is destination register, then another is targeted register. For example, for this one, he said 5RST. That means you add a bit pattern in the register S and T as though there were two complement representations and leave the result in register R. That means you add whatever value in register S and whatever value in register T, you add them, but those two values are all represented in two's complement format. Then you add the result stored in the register R. Now, for this example, 5726, this means you will add the binary value in register 2 and the binary value in register 3. You add them, then store the sum in the register 7. Because how do you know it's add? Because you say the output code 5. Okay? So let me stop here and get your feedback. If you have any questions, please send me an email. Now, let me stop it. Oh.